Hey guys, how's it going? So, on last Wednesday, our class in number theory had a quiz that was worth 10% of our grade. And I'm going to share with you the results and my experience during the whole quiz. So, as a reminder, like you guys might be wondering, well, you're not an expert at like this type of field. Well, like I said, I'm going to be like tutoring grade 10 to like ODEs in math. And like this stuff is outside my specialty. I'm not obviously not tutoring it. Well, maybe in the near future, depending on how well I do. But like this is just for fun to see. Like I'm able to teach something from the perspective of a master, but I like to be able to share with you my experience through the perspective of a student. So the quiz was worth 10 points. There was one calculation-based question and one proof-based question. Out of 10, I got a 7. The median was a 6 with an average of 65. In an upper division level class, at least in my university, they make it, they say that the average range is about a B. So I guess I'd be around the B or B plus range. So yeah, 10% above the median. This is what happened in a class of 84 students. The first question was about the Euclidean algorithm. This was very easy for me since I am a numbers guy. I love numbers. It's called number theory after all. And like find the greatest common divisor of 978 and 402 using the Euclidean algorithm. So the way you do it is like you say 978 is equal to 2 times 402 plus 174. And it's like, you see 978 and 402. Well, the greatest common divisor of 978 and 402 is the same as 402 and 174. Then you repeat that process again. So 402, 174 fits into 402 two times 174, and you get 54 left over, plus, which is plus 54. So GCD of 402 and 174 is 174 and 54. Then you do this process again, which you get 54 and 12. Then like the GCD of 54 and 12 is 12 and 6, and it's obvious that it's 6. And also because 12 divided by 6 gives you 2 with no remainder whatsoever. So then you get 6 as the answer. For part B, this question was a little funny. I did pretty well on it. I got 2 out of 3 on this question, but like I feel like I could have answered this question even as a 9th grader. Okay, so the question was, suppose the integer solutions to this Diophantine equation is given by x is -17 plus 38t, and y is 47 minus 105t, for t is an integer. And it says determine the integer solution with the minimum value of the absolute value of x, and justify your answer is correct. And then they just tell you the absolute value. Like I felt like I couldn't be the only one in this class to think that this was suspiciously too easy. Like I almost ended up not answering this question. Okay, but here's what I wrote. I said, like, I would imagine that using logic that the absolute value of x would be less than 38, because it's like, because of the 38t, so it's talking about x. And the thing is, it's like, because in division, it'd be like x is congruent to something mod 38. And if your absolute value of x is bigger than 38, then it's pretty obvious that like you can reduce it down. You can reduce the congruency to something less than 38. So it's like if x was say 49, then that's congruent to 49 mod 38, which is congruent to 11 mod 48. I'm not saying x is 49, I'm just saying if it was. So it's like if x was, the absolute value of x was greater than or equal to 38, it could have been reduced by a factor of 38. So like that means then t can be increased or decreased to find the lower lower value of absolute value x. So that's using logic. So then I said, let's look at the negative side. If x was less than 0, so At t equals 0, you would have gotten x is negative 17, plugging t equals 0 in here. This is the smallest possible negative value for x, since the 0 is less than or equal to the absolute value of negative 17, which is less than 38. So yeah, like negative 17 had the smallest absolute value in the realm of negative numbers, negative integers, I'm sorry. And then if x is non-negative, then your smallest absolute value of x, it would be 21. X is 21, and then this is the smallest possible value, since 0 is less than or equal to 21, which is less than 38. And because then 21 plus 38 is 59, then 95. Oh, sorry, it should have been 97. I realized this typo just now. And it's like 59, 97, 135, blah, 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 are all bigger than 21. There's also a pattern here, negative 55, negative 33, so on and so forth. Their absolute values are all bigger than the absolute value of negative 17. So then you can compare x is negative 17 and x is 21, but at x is, but the absolute value of negative 17 is smaller than 21. So the answer lies at x is negative 17 or t equals 0. And at t equals 0, y is equal to 47. So the answer is negative 17 and 47. So I talked to the professor today, and he's told me that because, like, well, this is my third time getting familiar with proofs. So if you guys do not know, I actually did not take real analysis, because like I'm the type of guy who likes to do computations and do interesting puzzles with numbers and such. So yeah, and like the professor said, this question was actually for the people who didn't really have experience with proofs to be able to explain something, hence the word I think, yeah, justify, yeah. I lost a mark because like you have to be careful, like what if t is less than 0? So because like I only considered positive t, so I should have said like showed why negative t would have not given a minimum value. I think I could have done that by some induction method or something. I'm pretty sure I could have gotten full marks, but that was an oversight. Yeah. So question 2, this was the proof-based question. I'm going to show you my method first before I reveal the correct answer. The question was, let a and b be integers, which are not both even. So that means either at least one of them would be odd, essentially. Let d be a positive integer such that d divides a and d divides b. And for any odd integer c, c divides a and c divides b implies that c divides d. And the question is, prove that the d is the GCD of a and b. And the hint is take c is equal to GCD of AB. I have to say GCD because this looks like freaking coordinates, honestly. It confuses the hell out of me. So basically, like, okay, I'll read my answer. Let c be an odd integer. This is usually how you start a proof. I learned it's like you let something be something. Let c be an odd integer such that c divides a and c divides b, and a and b are not both even. If c divides a and c divides b, then we have integers x and y, where ax plus by is c. Because remember, it said that you take c to be the GCD of a and b. So then you can write it out like this, basically, a linear combination, like a Diophantine equation sort of style. But this means that we can take the GCD of a and b equals c by the Euclidean algorithm. So then it says, no, you took c to be any odd integer, but it said for any odd integer c. I'm kind of confused about that. And then it said, you need to mention that this a and b is odd. I think, I'm not sure, but like, I didn't know that this was a thing. I'm gonna have to ask my professor on Wednesday in his office hours what this was all about. Then step 2 is, since C divides A and C divides B, that means C divides D under condition 2. So there exists an integer G where D equals CG, or C is D divided by G. I got a check mark for step 2, no points deducted. That changes our equation AX plus BY equals C to AX plus BY is D over G, because C is D over G. Then, so A times GX plus B times GY is equal to D. Note that GX and GY are both integers. So it's like D can be written, D, I said D was like the smallest, the greatest common divisor of A and B, because like A times GX plus B times GY is D, like I can write it as a linear combination. My terminal, I try to pretend I'm professional, but I'm really garbage. I try my best to sound professional, but it doesn't work. I'm about as professional as Alvin and the Chipmunks. Emotional damage to myself right there. I've never seen anyone diss themselves so hard without an emotional expression and talking really fast like I am kind of doing right now. Yeah, so AGX plus BGY is D. Note that GX and GY are both integers. Using the Euclidean algorithm once again, this means that the GCD of A and B is equal to D, as A and B can be written in a linear combinations and D is positive. This is like using greatest common divisors in Euclidean algorithm. But then it said, how do you know that it turns out that eagle, I thought it was eagle, it turns out it's Euclidean algorithm will terminate with D, so I lost a mark there. Before I reveal the correct answer, so it's like, I think this question, because like I'm sort of, I'll do proofs if I have to, but I'm not very comfortable with them. The way I try to do proofs is I try to minimize those creative steps that I have to take, because proofs can be very, very daunting. So it's like, I'm pretty good with pattern recognition, and like I've done this before. It's like, I know how to solve the equation of a plane here, I'll do it there and such. It's like, I see similarities. So the way I've noticed how a lot of instructors, when they give proof-based questions, they almost never tell us to prove something that was already proven in the textbook. Like this question I don't see in the textbook anywhere. It's not in a corollary or a lemma. So it's like, the way I studied for this is like, I read as many proofs and like constructed logical sequences in my head, not memorized, but I would know how to get from point A to point B. So it's like, if I could share this part of the textbook, it said, it was talking about like, if A and B were relatively prime and A divides BC, then A divides C. And I knew that in a proof somewhere, like because A divides ACX and BCY, then A divides C, because if you have a GCD on one side of the equation where you can divide an integer, you have to do it on the other side as well. So it's like, oh, I recognize that. Okay, I can use that for a proof. And like, yeah, it's the same way for the fundamental theorem of arithmetic, where you can get something is unique factorization. You prove by contradiction how if it's not, then neither side divides and such. It's like, so like seeing that, like I recognize that certain proofs use the same idea, saying that if A divides B and B divides C, then A divides C, because it's like, if on one side of the equation you can take out a common factor, then you have to on the other side. So it's like 3 or 4 proofs used this similar principle. And by reading more and more proofs, I generated more and more patterns and minimized the creative, like arbitrary bounds that I had to take. So honestly, I thought I would do worse. I thought I was lucky if I even got a mark, but now like I'm more comfortable with proofs, and I think I'll do better on the midterm. But I seriously wish the professor would stop writing like this. In my in calculus 3, like in the Discord, I remember some students were saying like, oh, we can't use the dot product for multiplication. We can't use the dot product and the cross product to express multiplication because they've been taken. And then some guy said, well, we can at least use parentheses now just to play it safe until that's used up. Well, it's used up right here. You can't use parentheses to express multiplication now after taking number theory because they're used for the Euclidean algorithm and something called Legendre symbols. Like I actually previewed number theory before the semester started. So that is all for today. This was my experience. And oh, actually, I almost forgot to share the, okay, so here's the solution to question number 2, that proof-based question. So apparently it's, we must have that A and B is odd for if A and B is even, then 2 divides. Oh, so that's why the GCD of A and B has to be odd, because if it was even, then 2 would divide the GCD of A and B, and hence 2 would divide A and 2 would divide B, being a contradiction. Okay, I think I kind of get it, but I have to go to look at this in depth. Okay, taking C equals AB, which is odd. We know that C divides A and C divides B, and hence using the second condition, we deduce that, oh yeah, that's kind of true. You see how like the proof is written in a way that from one step to the next, you're like, oh, it makes sense. Therefore, GCD of AB, that absolute value has to be less than or equal to D. Yeah, okay. I think I'd be able to get it after looking at this in depth. Yeah, but anyways, that is all for this video. I'd love to stay, but for now, I have to jump. I'll see you guys on the other side of the bridge. Catch you next time.